Hello, in this video, we will learn how to solve any number program. The programs which we are going to cover in this video are all the programs which require you to break the numbers in digits and do some manipulations on it, like palindrome number, pi number, neon number. There are some number programs which require you to find factors. We will cover those in a different video. If you Google on number programs, you will see huge playlists or lengthy blogs with multiple programs. So do you need to spend hours going through each of these programs and learn all of them? Answer is no. Like how you have a blueprint or a floor plan of a house and you just do customizations on it as per customer requirement. Similarly, what you need to do is learn a basic template and then you can solve most of the number programs by just tweaking it a bit. Before I explain the template, let's understand some basics with simple example program where we have to print all digits of a number on different lines. I'm using Java language over here, but if you know C, C++, you can continue watching as concept-wise it is the same. So the first thing is that we will assume we have some number n which we need to break into digits. This number has to be int or long as the logic which we will be using does not work on decimal numbers like float or double. Now you could be asked to write main and take in the number from user like using a scanner class. It is also possible that you are asked to implement program as a function where you get this number n as parameter. So for our program, I will assume we have got n from any of these methods and I will showcase the code starting from this point. I am assuming you do know how to fit the program in main or a function block and compile it. If you are still having any issues, you can view all of these programs on our website. Coming back to the program of breaking the number into digits. First, let me explain the logic which we are going to use. Suppose our number is 268. Now the way we will extract digit is that we will start by extracting the rightmost digit of a number. We will continue to cut out the rightmost number one by one till our number becomes 0. Now the first thing I want you to do is make a copy of this number. This variable m I might or might not use, but for almost 50% of the programs we will need this copy. And I see most of my students forget to write it, so I am making it part of the template itself. Once you have finished, if you see you are not using it, you can remove it later. We are going to use while loop to break the number in digits. If you do not know while loop, I would suggest you go through my video on basics of Java while loop first. Getting back to our code, we have already created a copy of our number n in M. What we will do is, we will set up a while loop till this number is 0. Then inside the while loop, we will first write the code to extract the rightmost number. How do we do it? We use the remainder operator with 10. What does this do? It divides the number with 10 and gives us the remainder. And what is the remainder? It is the last digit of the number. So now we have the last digit in variable d. Now in the question, we are asked to print this digit, so we will write system.out.println statement to print it. Now we need to cut out this number so that we can extract the next rightmost number. How will we do it? We will just do n divided by 10. What does n divided by 10 do? When you divide an integer number by 10, what it does is that it gives only the quotient without the remainder. So 268 divided by 10 will give 26 and it will drop the remainder as it is not a float or double number, so it cannot store the decimal value. So now the number will become 26. Now it will come back to while loop and it will check 26 is not equal to 0. It will enter the loop in second pass and again extract the rightmost digit in d. We will get 6 and we will print it. Then again we remove the digit we have extracted from n by dividing it with 10. We will have n as 2 now. Coming back to while loop, it will again check if it is 0. It is not so it will enter the loop for third pass. It will use % to extract 2 in D and print it. Then it will use division to cut out 2. Now we have 0 remaining in N. Now when it goes back and checks the while loop, since N is 0, it will come out of the loop and our program is finished. Now let's look at how the program will change if you are asked to write a palindrome program. What is palindrome number? It is a number which is same when written from the front or back, like for example 121, 24642 or 3553, etc. Here the logic we will use is that we will find the reverse of the number and then compare it with the original number to check if it is a palindrome or not. So what are we going to do? We have already created a copy of our number n in M. First we will declare a variable which will store the reverse. In the while loop, after we extract D, instead of printing we will form the reverse of the number. How will we do that? Every time we extract a number, we shift the previous digit we have in sum to left by multiplying it by 10 and then add the next number. So in pass 1, we will have 0 multiplied by 10 plus D, which will give the number 8 itself. Then in next pass, 8 will be multiplied by 10 and 6 will be added to it to give 86. Then in third pass, 86 will be multiplied by 10 and 2 will be added to it to give us 862. Now when we come out of the loop, we have to compare if this reverse number is same as the original. Now can you use n for comparison? Answer is no, because during this while loop, when we exit from pass 3, we have cut n down to 0. This is where the copy we made in M saves us. We will use it and compare M with sum. If M is same as sum, then we will print yes, the number is a palindrome, else we will print the number is not a palindrome. Now we have done 2 programs and from here you can see a template is emerging. All number programs require you to do some initialization, set up a loop to get individual digits, then put some logic in between as per the question, then cut out the number. Once out of the loop, there would be a check condition to say whether the number is palindrome or spy or any XYZ number or not. So this is the template which you will not change. We will now do different number programs by just using this template. Let's start with spy number. A number is said to be spy number if the sum of its digits equals the product of the digits. For example, number 123. Its sum of the digits is 6 and it is equal to product of digits which is also equal to 6. So here we need to find two numbers, sum of digits and product of digits, and then compare them. So in initialization, we need to initialize two numbers, sum equal to 0 and product to 1. Note that whenever we have to find product like in factorial etc., we initialize to 1 because if you initialize to 0, then on multiplication with 0, the whole result will become 0. Now in logic, we have to calculate sum of digits. So we will just write sum is equal to sum plus digits and product of digits is product multiplied by digit. How does this work? In the first pass, it will do 0 plus 3 and 1 multiplied by 3. In second pass, it will do 3 plus 2 and 3 multiplied by 2. In the third pass, it will do 5 plus 1 and 6 multiplied by 1. Then it will come out of the loop. So now in check section, you just check if the sum is equal to the product. This is a program for spy number. Now let's do special number. Special number is a number where if sum of digits is added to product of digits, it is equal to original number. For example, 59. Here 5 plus 9 plus 5 into 9 is 59. So here too we need to find two numbers, sum of digits and product of digits. but then we need to compare its sum with the original number. In initialization, we will initialize the two numbers, sum equal to 0 and product equal to 1. Now in logic, we have to calculate sum of digits and product of digits, so we will do that. Now in check, you have to find the sum of sum plus product and compare it with the original number. Here make sure you never use n for comparison, as you know it is 0 after the loop. So always use m when we compare with original number. This is a program for special number. Let's see next program, Harshad number or Niven number. It is a number which is divisible by sum of its digits. For example 156, if you sum up the digits, the answer is 12 and 156 is divisible by 12. Here in initialization, you will initialize sum to 0. Then in the logic section, you will find the sum. In the check section, you will check if m is divisible by sum by using the modulus operator to see whether it gives a remainder or not. If the remainder is 0, then it is a Harshad or Niven number, otherwise it is not. Let's see next program, which is the duck number. It is a number which has zeros present in it. Example 402, 280 are all duck numbers. So here you have to check the digits, and if any of the digits is 0, then it is a duck number. The logic which I will explain can be used to find any other number too instead of 0, or it could be used to count the number of times a particular digit occurs in the number. So here in initialization section, we will have count set to 0. In the logic section, we will just write a if statement to check if d is equal to 0. If yes, we will just increment the count. Now in check section, we need to check if count is greater than 0. If yes, that means it has zeros and it is a duck number. If the question was to print how many times zeros occur, you will just print the count. Instead of 0, you can check for any number and its count in this program by just changing the number in the if expression. Now let's do neon number. A neon number is a number where the sum of digit of square of the number is equal to the number. For example, if the input number is n, its square is n multiplied by n81. When you add 81, you again get 9. Here do note that you do not have to find the sum of digit of number. You have to find the sum of digit of square of the number and then compare it with original number. So first in initialization, you will initialize sum to 0. Then you will set n is equal to n multiplied by n, which is its square. In logic section, you will find sum of digits which is asked in the question. Then in check section, you will compare if sum is equal to the original number which is stored in the copy m. This gives you neon number program. Now let's do automorphic number. An automorphic number is a number which is contained in the last digit of its square. Example, 25 is an automorphic number as its square is 625 and 25 is present as the last two digits. Here we have the number and its square. The logic we will use is that we will break digits out of both numbers and then compare to see if they match. If any of them does not match, we will raise a flag. Once out of the loop, we check if flag was raised. Accordingly, we will declare the number as automorphic or not. So here in initialization, we will set a variable flag to 0 and find the square of the number in another variable q. In logic section, we will add the lines to extract digit from the second number, which is int d1 is equal to q%10. We will then compare d with d1. If d is not equal to d1, then we will raise the flag. We also need to divide the number q also by 10 to get the next digit of q. In our check section, we just need to check if flag is equal to 0. If yes, the number is automorphic. If no, then it is not. Now let's do Krishnamurti number or special number. It is a number which is equal to the sum of the factorial of all digits. For example, 145 is equal to sum of 1 factorial plus 4 factorial plus 5 factorial. Now here in initialization section,